Hey guys, wanted to take the opportunity to demonstrate my update to the Bioloid Beaglebone Black project. Um, I thought I was having some issues due to grounding, but that turned out not to be the case. I think it was an inductance issue. I think I was getting some crosstalk from the wiring that goes to the control uh, device for the servos, but I think I resolved that. I bound the wires more closely to the grounding line, and it seems like things have kind of cleared up. Again, the idea behind this project was that I wanted to use the Beaglebone Black to control the Bioloid in the dog configuration with as few or as little outside components as possible. And in particular, I wanted to keep the single USB host port on the device free. Um, you'll see the only real outside devices I have on this are a little arbitrator that I put together. It's just a couple of tri-state buffers, a couple capacitors, resistor, literally just $4 or $5 worth of parts. And that's for converting the uh, serial UART communication from the Beaglebone from two-line full duplex to a single line at half duplex, and also to handle the voltage conversion. Since the Dynamixels use 5-volt logic and the Beaglebone Black uses 3.2 volt. Also, I've got a cheap OV7675 camera that I use for this project. It costs about $5 online. Basically, everything is controlled by the programmable real-time units on the Beaglebone Black that are part of the Texas Instruments Satara processor that is the ARM processor that powers the Beaglebone Black. This way, you get real-time control over both the servos and real-time control of the camera while keeping the main board free to do pretty much anything else. And also, I'm keeping the USB port free, and I'm using a USB Wi-Fi mini dongle to establish a wireless network communication back to my desktop. What you're seeing here is the LXDE desktop being served out. It's by Xserve, and I'm using MOBA Xterm to connect to that. And you're actually seeing the desktop as it's running on the Beaglebone Black. I'm also in this project using OpenCV for doing simple motion tracking. The servo part is just running the same motion 512 motion page over and over. So that's kind of a part that's going to be have some more work done to it to allow communication between the main application processor and the real-time controller so that it can handle that. I'm going to go ahead and start up the project. That way you'll be able to see everything moving. It's communicating at 1 megabit per second. And it will also be tracking red colored objects. I'll start the project. You'll see two windows come up. One is for handling the motion tracking difference, and the other one is for actually showing what the video sees. Now you see the Bioloid is moving all 15 servos, and it's just going to do that same motion over and over. And what you'll see on the screen is the camera. Now the camera will be a little bit grainy because it doesn't do well in tracking motion. Let me keep this thing from sliding off the table here. But I'm now going to show, here's the camera, and I've got an orange ball, and it will track. You can see, give it a second refresh, you can see that black printed text is actually the reported position. Let me move it back into frame. It's the reported position of the ball. I'll try to hold still so it's a little bit easier to see. And again, it's just repeating the same motion over and over. But that is an actual motion page from the Motion 512 software that comes with the original Bioloid kit. So again, the main processor is able to maintain a desktop and keep everything going that you would normally expect. The real-time controllers on the Beaglebone Black are controlling the servos and taking the feed from the camera. And again, it's a $5 camera, $4 or $5 worth of parts for the arbitrator. USB port's still free. It has that Wi-Fi dongle, and that's how we have our wireless connection back. You notice the processor is kind of pegged on the Beaglebone Black, but that is probably more to do with the getting the desktop, the remote desktop session video stream back to the desktop than anything else. Again, the real-time units are actually handling most of the work on the system as far as controlling the servos and getting the camera feed. I'm going to go ahead and stop the project. All right, hope you guys like that. I'll be posting the source code. Right now the source code is hosted on SourceForge, but I'm actually going to move the repository over to GitHub. And see you around. Thanks.